Good morning, dear children. I welcome you all to E-Class Learning 10th Standard Science under MDES Mysore. Children, in last session, we have studied about physical properties of metals and non-metals. Now in this class, let's study about chemical properties of the metals and non-metals. Every metal or non-metal has a certain chemical characteristics. They react, they combine, but there is a certain pattern. It just cannot be like sometime it is reacting, sometime it's not reacting. So, science totally work upon certain laws. When we talk about sodium and potassium, these are the metals which react most. If we keep sodium and potassium in open air, it is going to catch fire. In this chapter, we understand how reactive each metal is. For example, if you take the alkali metals like sodium and potassium, they react vigorously. Even in a room temperature, they are reacting with oxygen. So, when sodium and potassium combines with oxygen, gives their respective metal oxides. In the sense, when sodium combines with oxygen, it gives sodium oxide. The reaction is sodium plus oxygen, Na plus O2, gives rise to Na2O, that is sodium oxide, that is chemically balanced equation. When potassium reacts with oxygen, it gives potassium oxide. The reaction is K plus O2 give rise to K2O, potassium oxide. So, now tell me that which are the metals react with air at room temperature? Yes, correct. Sodium and potassium. Is it clear, children? Till now, we have studied that metals like sodium, potassium reacts in room temperature. But not all the metals have same property, which means most of the metals won't react in room temperature. Examples are magnesium, copper, aluminium, etc. When these metals react, it reacts when we heat. Did you understand? So the reactions are follows. When the heat is supplied to magnesium, the reaction is Mg plus O2. Magnesium with burnt oxygen gives rise to magnesium oxide, that is MgO. That oxide is white in color. Children, magnesium burnt in oxygen. This experiment have shown in last chapter. I hope you all remember. Next, copper reacts with oxygen. That means copper burnt in air, Cu plus O2 give rise to CuO. Copper oxide is formed, that is black in color. When heat is supplied to aluminium, the reaction is aluminium plus oxygen Al plus O2 gives rise to Al2O3, that is aluminium oxide is formed, that is white in color. Till now we have seen metals which are react with room temperature and its chemical reactions, and the metals which are not reacting with room temperature are metals reacts when heat is supplied and their reactions. Okay, is it clear, children? Now tell me, which are the metals react when heat is supplied? Yes, good. Magnesium, copper and aluminium. Children, you have studied acids and bases in your last chapter, isn't it? You remember that till now in this class we have studied about metals reacts with oxygen to form metal oxides. Now, we know about metal oxides too. Some metal oxides which react with both acids as well as bases to produce salts and water are known as amphoteric oxides. Examples such as aluminium oxides, zinc oxides show both acidic as well as basic behavior. So the amphoteric oxides means metal oxides react with both acids as well as bases. So the reactions are aluminium oxide, that is Al2O3 plus HCl hydrochloric acid gives rise to AlCl3 aluminium chloride plus water. Equations are chemically balanced. Aluminium oxide, same aluminium oxide Al2O3 reacts with sodium hydroxide, the base, gives rise to sodium aluminate plus water. Like that, similarly, zinc oxide react with hydrochloric acid ZnO plus 2HCl gives rise to ZnCl2 plus H2O, zinc chloride and water. Zinc oxide ZnO reacts with the base sodium hydroxide 2NaOH gives rise to sodium zincate Na2 ZnO2, that is sodium zincate plus water. Now let's see about metals react with water, that is in cold water. When you put sodium and potassium in a different jar which contains cold water, you will observe sodium vigorously begins to start running around the water and catches the fire. Potassium catches very fire immediately. That's why to protect them and to prevent accidental fires, they are kept immersed in kerosene oil. The reactions of sodium and potassium with water is shown here. Sodium Na plus water H2O gives rise to sodium hydroxide, that is NaOH plus hydrogen gas, burns vigorously. Potassium, that means K plus water H2O, it gives potassium hydroxide and hydrogen gas. If you put calcium in cold water, calcium does not react that vigorously. The reaction is Ca plus 2H2O water gives rise to calcium hydroxide CaOH twice plus hydrogen gas. The hydrogen gas does not burn so vigorously. If you try with other metals, the reaction is fails with cold water. Next we will try with hot water. Magnesium in hot water gives magnesium hydroxide. The reaction as follows. Magnesium Mg plus water H2O, 2H2O gives magnesium hydroxide plus hydrogen gas MgOH twice, that is magnesium hydroxide. Liberated hydrogen gas bubble onto the magnesium. Therefore, magnesium floats. The other metals fails with hot water. Till now, we have seen metals react with room temperature. When heat is supplied to the metals, metals react cold water and hot water. Now let's see metals fails to react with above conditions. They are aluminium and iron. They react with steam. In general, the more reactive the metal, the more rapid the reaction. Aluminium is unusual because it is a reactive metal, does not react with water. Its surface forms a protective layer of aluminium oxides that keeps water away from the metal below. The apparatus used to react a metal with steam and collect the gas produced is shown in the diagram. Metals like aluminium, iron and zinc do not react either with cold water or hot water, but they react with steam to form the metal oxide and hydrogen. The reaction of metal with steam is aluminium plus steam, Al plus H2O gives rise to aluminium oxide plus hydrogen gas. Iron Fe plus steam H2O gives rise to Fe3O4, that is iron oxide plus hydrogen gas. Next, metals like lead, copper, gold and silver, they don't react with water, that is cold water, hot water and steam. Then we move to the acids. Let's choose hydrochloric acid first. When we add potassium and sodium to cold water, it reacts vigorously. Imagine potassium sodium reacting with dilute hydrochloric acid, almost explosive. Hydrogen released is going to burn and oxidize to water. Don't do that. Never take a sodium and potassium into this experiment. That is too reactive. Let's take magnesium. Pushes it into hydrochloric acid. Magnesium reacts with dilute hydrochloric acid. Magnesium forms its chloride and releases hydrogen gas. Mg magnesium plus HCl hydrochloric acid gives rise to magnesium chloride MgCl2 plus hydrogen. To test the hydrogen gas, pop sound will come. Next, aluminium reacts with hydrochloric acid gives rise to aluminium chloride Al2Cl3 with liberation of hydrogen gas. We need to observe hydrogen gas liberation. What is the rate that the bubbles are coming up? That tells the rate at which these reactions are happen. Let's also try with zinc ion. Observe which of the cases the bubbling is most. It in the case of magnesium. Therefore, magnesium reacts fastest than aluminium, than zinc, than iron. The reaction of zinc with hydrochloric acid is Zn plus HCl gives rise to zinc chloride plus hydrogen gas liberated. Iron plus hydrochloric acid, that is Fe plus HCl, gives rise to FeCl3 plus hydrogen gas. These all the equations are chemically balanced. Next, the metals like gold, platinum, these elements react with anybody. We need to find someone. That is aqua regia. It's a kind of mixture of 3 parts of concentrated hydrochloric acid and 1 part of concentrated nitric acid. It actually dissolves gold and platinum. Children, next we will see that the metals react with solutions of other metal salts. For this, let's take a couple of test tubes. Let's add copper sulfate solution and other let's add ferrous sulfate solution. Dip iron nail in copper sulfate solution, copper wire in iron sulfate solution. Keep this apparatus after some time. Copper sulfate solution begins to turning its color and iron nail looking little ugly. That means reaction is taking place. The metal is more reactive than the metal salts, which is copper salt. Iron displaced copper. In other test tube, no reaction takes place. That means iron is stronger than copper. The reaction is Fe, that means iron reacts with CuSO4. Copper sulfate solution gives FeSO4, ferrous sulfate plus copper. You must know that which one is more reactive in our previous experiences. Copper did not react with many substances. Iron nail inside the copper sulfate solution, you could see that copper getting deposited around the iron nail, getting copper outside from copper sulfate solution. This is called displacement reaction. Okay children, in this class we have learnt about different chemical properties of metals and their mathematical representations. Children, let's wind up this class with some assignments. First, why is sodium and potassium kept immersed in kerosene oil? You should give reason. Second, draw a neat diagram of action of steam on a metal and make its parts. What are amphoteric oxides? Write its equations. Fourth one, write chemical equations of magnesium and zinc reacts with hydrochloric acids. That's all for today. You should answer all the questions without fail. Let's discuss further information in next classes. Thank you children.